Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. And in this video, we're going to do something kind of odd when we're talking about Taylor and Maclaurin series expansions for functions. We're going to feel like we're rewinding a little bit, finding the sum of a series. However, we were not able to do something like this previously, so that's why it's in the material mixed with Taylor and Maclaurin series. We've just learned a few, specifically 3 through this video series, 3 Maclaurin series representations for popular functions. So we had like e to the x is equal to the summation n equals 0 to infinity of x to the n over n factorial, right? We also found out that cosine of x was equal to the summation, again, n equals 0 to infinity. It's alternating, -1 to the nth. And since cosine's an even function, our power should be even on our x's, and it's 2n factorial downstairs. And the sine of x, since it is an odd function, it'll look like the cosine as far as structure goes, but because it's an odd function, it'll have odd powers on x, 2n plus 1s over 2n plus 1 factorial. Now, like I said, we were not able to approach the type of problem that we see right now with this example until this moment. If you take a look at the powers on everything and also the factorial itself, you could see that this 2n plus 1, this 2n plus 1, and this 2n plus 1 are identical. And they kind of have the form of this right here, the sine function. In fact, we even have the alternating part involved. So what I'm going to do is factor out a 5 from that power series. I'm also going to clean up the this pi to the 2n plus 1 over the 6 to the 2n plus 1, and I'm going to glue them together. It's just pi over 6 to the 2n plus 1. And that's over 2n plus 1 factorial. It's kind of a quick example, but it's part of our kind of goal in mathematics is to really reinforce our pattern recognition skills, to be able to look at something and say, oh, I see this is sort of like a sine expansion. I would just like not to have a 6 to 2n plus 1 downstairs, but instead to just have something to the 2n plus 1 in the numerator. And that's exactly what we have here. And we know that this is going to be 5 times, that expansion right there is the cosine of, instead of x, which let me highlight that here, sine of x would be all that stuff with an x. We actually don't have an x, we have a pi over 6. So we are actually looking at the sine, not the cosine, sorry, the sine of pi over 6. And of course, trigonometry is a prereq for all the calculus series, so this is going to be 5 times a half or 5 halves. So I hope that was helpful.